served as a technical committee member of the IEEE Technical Committee on Intelligent Control, IEEE Consumer Electronics, Power and Energy, IFSC Computational Intelligence in Control, Steering Committee member of the Asian Control Association, member of the IFSC Council, and Vice Chair of the IEEE Technical Committee on the Consumer Electronics, Power and Energy. He served as an editor with the IEEE Transaction and Sustainable Energy, IEEE System Journal, IEEE Access and IIT Electronics Letter. His research interests include system and control of power systems, embedded systems, and AI and machine learning. He has supervised 40 PhD students, published 164 peer-reviewed journal papers, 110 papers in conference proceedings, 14 book chapters, and 8 books. Sir, kindly proceed with your technical session. Please, sir.
Session chair ki achi?
Okay, so thanks for the invitation, and my topic will be on computation. My topic will be on computational intelligence for modeling and control of PV system, fixed photovoltaic system. I will be speaking on three aspects. One is the bacterial foraging optimization technique that has been used by me and my research group to design to extract the parameters of PV panels. And the second problem I will be discussing the application of the technique on the gray oak optimization technique for maximum power point tracking of the solar panels. And the third one is the reinforcement learning controller for the grid connected PV system. So these three I will be briefly speaking on the topic. So we discussed in the inaugural session the computational intelligence. It is basically, if you look at this traditional AI and versus the different kind of techniques, you see the fuzzy logic, probabilistic reasoning, maybe genetic algorithms or neural networks, evolutionary programming, and then the artificial life, and many evolutionary computation technique are falling in this bucket. So you see the computational intelligence, when you say, primarily we see the four brackets of computing. One is granular computing, then neurocomputing, evolutionary computing, and artificial life. And out of those, the granular computing comes under the bracket of fuzzy sets theory, rough set theory, and probabilistic reasoning. And if you talk about this neurocomputing, it would be either supervising or unsupervised learning or reinforcement learning.
Keynote कितना सुना?
So, if we talk about this evolutionary computing, we have a lot of things coming in, like genetic programming, genetic algorithms, swarm intelligence, like differential evolution. A lot of members have come in this bracket. Now, artificial life is another way of computing. So that is the artificial immune systems, like hand-followed optimization. So many optimization techniques. So I will not speak on that different techniques because it will take a lot of time and all that. So what I say that the computational intelligence are the obvious regions of the characteristics they have in complex systems when not enough information are available or enough data is available or information is not available. So in those cases, we get the global solution, the global optimization. So one of the approaches is to use the computational techniques for optimization. So I have primarily I am working for the last 10 years on the photovoltaic systems. And in the photovoltaic system, primarily there are several issues. One issue is how to harness the maximum power of the panels. For that, you have to model the parameters. So how to model, how to estimate the parameters. So that's also optimization problem. And then the next one is how to forecast the solar irradiance of insolation so that the grid stability when you integrate the panels to grid can be ensured. And the next one is like the control aspect, like how to extract the maximum power. This is called maximum power maximum control. And the next one is the maintenance aspect. So all of these aspects like design, forecasting, control and maintenance, all of them the professional intelligence will be used, and some of them I tried in my research group. And the first one I will talk of the parameter extraction using the bacterial processing optimization. What we do here, we have a solar panel or a module, and then we measure these parameters like open circuit voltage and short circuit current, and then we get the key entities which is written in the panel. So with this information, we have two things, that is the global P is the solar radiance and then P the temperature. With this, then we have the analytical calculation if you make. You may not get the kind of optimal parameters of the panel. So what you do is we employ some this bacterial foraging optimization technique so that you get three parameters optimized on the panel parameters and the sound resistance and the parallel resistance and the ideal factor of the panel. So this detail of this paper I am not going on this. This is available in IMIT Transition Software Energy 2018 for the details. What primarily we have done, there are different models available in the photovoltaic. I believe most of you are very popular with photovoltaic panels. So this photovoltaic panel is basically modeled as a single diode model or a double diode model. So if you choose a single diode model, these are the some equations. So how the panel output current, diode current and all that are found out. And then these are some of the definition of these panels. So what we do, we find that there are different methods of finding the parameters of the panel. What are the parameters? If you look at the parameters, the previous one, the parameters are like RH, the series resistance, sound resistance, and then we have the panel voltage and current. So these are some of the parameters. So what we do here, we just take the classical method of identifying those parameters, and then we apply different intelligent techniques, starting from the logic control method.